In this video, I'm going to be demonstrating the implementation of an AWS Hybrid DNS design and architecture between an AWS region hosting private-only subnets and an on-prem private corporate data center. I'll be going over the architecture and procedure steps documented in my runbook here, which I'll also link to in the show notes of this video below. The intent of this design is to simulate a hybrid DNS cloud connectivity setup to an on-prem environment using something like AWS DirectConnect or AWS VPN. However, the actual implementation is going to provide private DNS resolution over an established inter-region AWS VPC Peering connection through various Route 53 services and Linux Bind DNS server components as described in the procedure documented below. I've outlined some of the prerequisites in order to perform this implementation, which includes having a GitHub account, an AWS account, AWS configuration and credentials set up, as well as Terraform installed. Terraform will be used to deploy our entire infrastructure. Some of the design artifacts are listed here, including a recording of this video, a couple diagrams, which we'll be going over next, as well as the location for the repository containing all of our Terraform artifacts. There's also a guide here from AWS on how to set up integrated DNS resolution for hybrid networks in Amazon Route 53, which is basically what we're doing today. So let's hop over to the simulated diagram here and kind of talk about the idea behind this, what we're possibly looking at implementing in a live scenario. So we've got on the left our micros for L AWS VPC. This is our US East 1 region, which will be hosting all of the Amazon Route 53 services. And the way it's going to connect to our corporate data center on the right is hypothetically through a direct connection. The corporate data center hosts our DNS servers, as well as an application server, and it's on a totally separate private network from our US East 1 VPC. So this is the hypothetical design. Let's hop over to the actual design to help with further clarity. So here's our actual AWS Hybrid DNS design here. And again, on the left, we've got our US East 1 VPC for micros for L AWS, where Route 53 will be hosted. And then on the right, I've selected a completely separate region in AWS to simulate this in US East 2. So looking at US East 2 here, which is our micros for L on-prem VPC or the corporate data center, I've got a VPC here, again, of 192.168.10.0/24. It's going to contain two separate private subnets, A and B, which will be connected to the on-prem DNS A and on-prem DNS B EC2 instances, respectively. Additionally, the zone for aws.microgreensforlife.org zone here is going to be configured as a forwarder set in the DNS A and B server zone named.conf config file. And this will allow for resolution to our AWS private hosted zone through an inbound endpoint resolver hosted in the US East 1 VPC here. So it's going to point the forwarders to the IP addresses hosted here. Meanwhile, the actual corp.microgreensforlife.org domain is living in this isolated VPC or the corp on-prem environment. Now hopping over to our US East 1 VPC here, we've got a totally separate prefix of 10.10.0.0/16, which also is going to contain two separate subnets here on private-only subnets. And these will be hosting just these plain AWS EC2 instances that we'll be using for testing outbound DNS. The Route 53 private hosted zone for aws.microgreensforlife.org lives here. And it also has an A record for the subdomain web.aws.microgreensforlife.org. So we've got also, as noted earlier on this side, we've got an inbound endpoint resolver, which is going to resolve requests from our on-prem VPC inbound into our AWS VPC to resolve our subdomain for web.aws.microgreensforlife.org. But we also have an outbound endpoint resolver, which includes a forwarding rule for the corp.microgreens.org zone or domain, which it routes to routes DNS requests to the on-prem DNS A and B servers out through the VPC peering connection to be resolved back to these EC2 instances. So all these instances on both sides of this connection are deployed with settings configured to allow systems manager connectivity. This is the only way that we can have basically like a console access into the devices to perform our testing. And on the right side here for our on-prem DNS servers, we'll be making some modifications to the configs on these servers as well. There will be no public IP addresses assigned to any of these environments. It's completely private, and obviously no internet gateways are going to be deployed here. And also I wanted to just note out that we've got two totally separate non-overlapping CIDRs being implemented in each VPC. So when you do a VPC peering connection or even a direct connect or VPN, you have to have non-overlapping IP addresses between your environments in order to successfully communicate. So without further ado, let's head on over to our repository here and kick off our implementation. So the first step in the procedure, it says to go to the, here we'll navigate to our AWS Terraform Hybrid DNS folder. The first step says to go to the global IAM directory and run a Terraform plan and apply. I've already done this and I never did a destroy because this side simply just, it implements an S3 bucket for my Terraform state files for all of the environments or the modules holding our Terraform files. And it also creates an IAM role for the EC2 profile, as well as policy attachments for all of our EC2 instances to utilize. And so this isn't really accruing much cost. I mean, the IAM profiles don't cost anything, and the S3 bucket, it should be negligible. So I've left it there. But if you haven't deployed it, you want to do that. If you want to have your state file saved to an S3 bucket, you'll also need to update your bucket name to something that's globally unique, as it won't create for you. So I'll go ahead and close that, and we'll move on to step 2, which is to navigate to the US East 2 directory. So this is our Ohio directory, which is hosting our simulated on-prem environment. So I'm going to go ahead and navigate into our folder structure here, US East 2, and I'm just going to go ahead and kick off and apply here, and we'll talk about what's being created as it's deployed. So while that's running, we can kind of talk about what this is creating, starting off with the EC2 file here. So again, this is our on-prem environment, and this is going to be deploying our security group for on-prem, which is going to allow our access into the systems manager settings. I'm going to go ahead and hit yes here so we can get this going, but ideally you'd review your config and understand what's being created. So I'll hit yes. So that is creating, back to the security group here, we're going to allow SSH so that we can do a systems manager connection to our EC2 instances. We have to allow HTTP and HTTPS in and outbound in order for systems manager processes to work, as well as DNS inbound and outbound, both on TCP and UDP, need to be opened up for our inbound and outbound DNS resolution to be successful. Then we've got our on-prem DNS A, as well as our on-prem DNS B EC2 instances being deployed. And these do come with a a user data script so that when they're booting up, they're going to install bind utilities so that we can install basically the DNS server components on here. And as well as it's going to come with additional DNS settings so that we can resolve our requests to our locally hosted corp.microgreensforlife.org zone and domain, and a couple other settings for DNS resolution to work. And then it's also going to, every one of the instances in this environment is going to have the SSM agent installed in the user data script as well. So that's on-prem DNS A and B EC2 instances. And then we've got our on-prem app instance. And this is just a really vanilla Linux EC2 instance. It's basically just set up with SSM so that we can test DNS resolution for the subdomain of app.corp.microgreensforlife.org. So that's the EC2 piece. Scrolling down here, I'll go to VPC, even though VPC is obviously got to be created first. There's an order of operations here. So it's going to create all the VPC resources and then the EC2 resources. So the VPC, like I said in the diagram, it's 192.168.10.0/24 CIDR block. And it's going to create private subnets on two separate private subnets in two different availability zones so that we have a high availability mesh. And each of the two instances, the on-prem and on-prem DNS A and B, are going to utilize one of each of those subnets. It's also going to create the private route table and associate those subnets to the route table, and then create all these VPC endpoints that are required to get SSM, which is a systems manager connectivity, to work. And that's basically it in a nutshell. Now you'll notice that the Terraform apply finished. So we've created all of our resources here. And it did spit out some outputs that we're going to need these values for these objects that were created in this Terraform apply in the next step for the US East 1 deployment. So I'm just gonna copy these and drop them in a text file here so that I can just grab them quickly on the next step. Now I'm gonna hop over to US East 1, which is our AWS environment where we have Route 53 services created. And I'm gonna go ahead and get that deployed so that we can get that going. And once these are deploying, I'll show you the console of the US East 2 resources that were created using that Terraform apply in Ohio. So I'm going to Terraform apply on my US East 1 environment here. And while that's going, I'm going to wait for these, inputs to kick off here. So it's going to ask for my route table ID of the acceptor that you want to peer with. We're going to be establishing the VPC peering connection in this step in the Virginia region. And this route table ID comes from our on-prem US East 2 environment. So we're going to paste that in here. And then also the VPC ID for our on-prem environment needs to go in here as well. And then the private IP addresses of our DNS A and B servers need to get configured here as well. So I'm going to get these entered here, and I'm going to let this load the Terraform apply for me. I'll hit yes to kick it off, and then we'll hop over to the AWS console to kind of talk about what was actually deployed back in Ohio and US East 2. All right, so this is going to go and it's going to prompt me. All right, so we've got our apply is ready to go. I'm going to hit yes. Let's get that going and let's go look at. So this is our North Virginia. We're deploying here right now, but let's look at Ohio and US East 2. So again, this is our on-prem simulated environment. And we need to refresh our screen here, I think. Oh. Let's see. All right, so I had to go ahead and re-authenticate into the console there. So I've kicked off this recording again, and now we're back in Ohio here. So US East 2, which is our simulated on-prem environment, you can tell by the name, where we've created that 192.168.10.0 VPC. We can see that our subnets were also created here for on-prem private A and private B, utilizing that VPC on the 192.168.10/24. We've got our on-prem private route table that was created here, and those two private subnets have been associated. We can take a look at our routes here. And we've got our local route that's standard with every private route table that you get created that when you associate your subnets. We've also got this PL, it stands for prefix list, to this VPC endpoint, which is that S3 VPC endpoint, gateway endpoint that gets created. And this is just to utilize systems manager connectivity. And you can also see here that we've got our 10.10/16 destination with our peering connection has already been created because we kicked off that US East 1 Terraform apply. So that's already been created, and we've already got routes over to our AWS environment. So we are all set to get going with testing out DNS and pinging connectivity. So those are the basic routing setups. Here's our endpoints. Like I was saying, for systems manager, we need to have these VPC endpoints created. Here's that S3 gateway, which had that special route in the route table for it. And then we've also got our security group that was created here. So our on-prem security group with the inbound rules that I went over earlier in the code, as well as the outbound rules so that we can establish ICMP pings and DNS connectivity, and then the HTTPS rules for the systems manager to work. I think that's about it for VPC stuff. Let's go ahead and look at the EC2 instances that were created. We'll click on running instances here. And we've got our on-prem app, which is going to be used to test our app.web.microgreensforlife.org DNS, as well as on-prem DNS A and B. These are the two servers that are running Bind and hosting the zone file for corp.microgreensforlife.org. Yeah, so let's see where we're at here on our guide. So we've captured our outputs, we've deployed US East 1. We can go ahead and flip over to US East 1 now and just take a look in Virginia here. This is our AWS environment. See that our AWS VPC was created, as well as the private subnets, the route table, AWS route table here. Subnets were associated, routes were created, including the peering connection here, which we can take a look at as well. I think that was just an old peering connection I had. And this is the new active one that is going to allow us to have access from our 10.10 CIDR range to the 192.168.10 range in US East 2. And also we did have the same VPC endpoints created here so that we can have systems manager connectivity, and the security group rules should be the same so that we can allow SSM connectivity, SSH, as well as DNS for both inbound and outbound. And so we'll go ahead and hop over to, actually, before we go to EC2, let's take a look at Route 53, because this is where we have our Route 53 hosted private zone created. And we see two zones here. I've got one for something else, my personal website, but I've also got an AWS.microgreensforlife.org private Route 53 hosted zone created here. And you can see I've got the name server and the start of authority, which is required for every zone that you create. In addition, I've got this web.aws.microgreensforlife.org A record. And this A record points the traffic to these two private IP addresses, which actually represent our EC2 instances that were created. So we've got a .198 and a .202. Let's go to EC2 instances. And we can see the .202 and the .198 created here for our AWS EC2 A and B instances. All right, so I think that pretty much covers it for step 4, except for we didn't look at the Route 53 endpoint resolvers. Let's look at those real quick. So we've got a resolver for inbound DNS resolution here. And this is for our M4L inbound connectivity. And this is going to resolve basically any DNS requests that are coming from our VPC peer over in US East 2 or Ohio that are trying to hit our aws.microgreensforlife.com subdomains. And it does assign private IP addresses on each of the different subnets that we have configured here, which cover the 2 availability zones. And then we've also got this outbound endpoint resolver, which does have a rule associated with it. And this also gives it an IP address from each of those subnets and availability zones as well. And then we can see our rule down here. It's called M4L Corp Zone. And so basically it's a forwarding type rule that says any requests originating in this Virginia region that are trying to hit corp.microgreensforlife.org subdomains over in US East 2, Ohio, our on-prem environment, would go across our VPC peering connection and target these 2 IP addresses, so .81 and .210, which are our 2 on-prem DNS servers here. And that's how we establish outbound DNS resolution. So that should explain both the US East 1 and US East 2 environment resources that were deployed here. And it looks like we're about at step 5 in the procedure document. So let's flip back over to our repository here. And you'll note that when I deployed the Terraform apply on US East 1, it gave me this output here. And what we need from this output, these are the inbound endpoint resolver IP addresses. And we just need to grab these 2. And I'm just gonna drop them right here because we'll need to configure these in a later step. In actually the next step in the AWS zone.forward file, which will configure manually on our on-prem DNS A and B servers. All right, so let's open that zone file. And what we can do is we can just basically, you want to highlight this holding variable here. So this is the first IP in this resolver list, and then paste that in there. And then the second one, make sure you leave those semicolons there. And now we're gonna, I'm just gonna copy this and we're gonna go back to Ohio and we're gonna connect to our on-prem DNS A and B servers. And we're gonna configure the name.conf file to include those inbound endpoint forwarders. So I'm going to go into sudo and I'm going to vi the etc named.conf file. And I'm going to scroll down to the end of the file and start off a new line and paste this zone contents for aws.microgreensforlife.org to include forwarders to those inbound endpoint IP addresses that live over in the US East 1 environment. I'm going to save this file. I'm going to systemctl restart named service, which is our bind service. So running our DNS resolution for this change to take effect. And you can check the status of it if you like, but I'm going to trust that it worked. And I'm going to go ahead and run a dig against the web.aws.microgreensforlife.org subdomain hosted over in US East 1 against my local host DNS server here and see if it resolves. And it did. So we resolved to the 10.10.10.198 and the 10.10.0.202 IP addresses, which are our AWS EC2 A and B hosts here, which are the hosts for that particular A record in Route 53 under the private hosted zone. We can just double check that again. Right here. So that validates that our inbound endpoint resolution is working successfully from US East 2 in Ohio to US East 1 in Virginia. So on-prem, hypothetical on-prem is now resolving AWS Cloud DNS using the Route 53 services. So let's go ahead and do the same thing on on-prem DNSB. I'm going to connect to the session manager. I'm going to close that DNSA. I'm going to sudo and vi the named.com file. Scroll to the bottom, kick off a new line, and oh, that's right, my bad. We'll redo that. Copy this. And insert, paste. And again, we're doing our zone for the AWS Route 53 private zone with the inbound endpoint forwarders. Save this. System cuddle restart named, and then we'll run a dig test to that AWS subdomain against our local host here. And there we go. We've got the same results as on-prem DNSA. So that part is finished. So now we're going to go ahead and log into our on-prem app instance here. Get the session manager going. And once that's getting set up, I'm going to go ahead and just copy from step 8. And this is where we want our private IP address of the on-prem DNSA and DNSB servers. And that was given to us on the very initial deployment to US East 2. So I'm going to grab that because I'd already saved it. And we're going to just hard code our on-prem app server here to point its DNS lookups to those on-prem DNS A and B servers for resolution. So I'm going to enter sudo. And then we're going to go into the network configuration settings for this server and modify the East 0 configuration. Scroll to the bottom of this file and new line, paste, save it. And when you make a change to a system or a network settings like this, you want to do a system cuddle restart of the network services. I must have had a typo there. All right, so we're going to go ahead and we'll test ping against the subdomain of the web.aws.microgreensforlife.org over in US East 1. And it is successful. And then we'll just do a dig to see the results. And here we go. We've got the same results as the on-prem DNS A and B servers. This on-prem app server, again, it's sending its DNS request to those on-prem DNS servers to look up the resolution for our web.aws.microgreensforlife.org subdomain. Perfect. So this validates that we've got EC2 instances hosted in Ohio here which is our on-prem environment, they're successfully resolving DNS lookups to our AWS Route 53 environment in Virginia and US East 1. So to complete the task here, let's go flip back over to US East 1 in Virginia and go to the EC2 instances. And we're just going to validate that we can do the same, but from our EC2 instances here to resolve our subdomains over in US East 2. So make sure you're in the right region. I'm in Virginia. Okay, I've got AWS EC2 A and B. I'm just going to test EC2 A. And I'm just going to run a ping here. Again, we're on step 9. So I'm going to run a ping against app.corp.microgreensforlife.org. And it's successful. I see it's resolving to this 192.168 IP range. So that's our Ohio environment, our Ohio VPC. And we'll just run a dig. And it's resolving to 192.168.10.154. So this .154 IP address is being resolved to this app.corp.microgreensforlife.org subdomain, which is actually the on-prem app IP address here in Ohio. And it's getting this from the config set in the bind server. So on-prem DNS A and B has this zone file here under named, and it's got this host name lookup which gets assigned to that on-prem private IP address. So that's how it's resolving that subdomain. And that's it. We've now established connectivity interregionally for both pinging as well as DNS. And the next step at this point would be to, you don't want to be accruing charges for all these instances. So simplest way to destroy would be the Terraform destroy. And step 10 walks through those instructions there. I'll go ahead and just I'll kick off one of them in US East 1 here, because you do get prompted for those input values. And let's just quickly go through that real quick here. So I just run a Terraform destroy in US East 1, and it's going to ask for the route table ID. I do have an ignore rule on that, so we can just bypass that. And then it's going to prompt for the on-prem DNS A and B private IPs, and I couldn't figure out how to get an ignore rule on those. So you're going to have to just enter those from these on-prem DNS A and B IP addresses here in order to get through the Terraform destroy. And it's going to load the output for what it's going to destroy and prompt you to confirm that. And we'll just wait a minute here for it to do that. But basically, you'll be doing the same activity for US East 2. And there aren't any prompts in US East 2, so you can just go ahead and run the destroy there. And if you like, you can also destroy the global IAM environment as well. But like I said, it's just the S3 bucket for the state files as well as the EC2 instance role. All right, so let's go ahead and just do a quick summary here of what we were able to implement and test out today. So we were able to create 2 separate environments that were completely isolated on private networks, and we were able to successfully integrate DNS resolution between these environments. The private AWS VPC instances that were hosted in US East 1, we validated were successfully resolving all of our corporate subdomains that were hosted in our hypothetical on-prem VPC over in US East 2. And they were able to do so by traversing this outbound endpoint resolver with the forwarding rule for the corp.microgreens.org zone. And then we were also, on the flip side of that, we were able to validate that the private on-prem instances over here in US East 2 were successfully resolving the web subdomain hosted in our private AWS VPC US East 1 environment via this inbound endpoint resolver. So thank you today for joining me along on this demonstration of an AWS Hybrid DNS deployment using Terraform. And please do note in the comments below any thoughts on how we could possibly improve this, or how you might be deploying something like this in your environment. Are you using CloudFormation stacks? Are you using Terraform? I'd love to hear your feedback, and thanks again for watching.